All right, so now we're going to use a general strategy to solve linear equations. Okay, so this page is probably a really good page for you to read through. It's important that you understand the basics of this. So you do want to, number one, simplify each side of the equation as much as you possibly can. Then you want to collect all the variable terms on one side and collect the constant terms on the other side of the equal sign. And make the coefficient of the variable term equal to 1. So that means you're going to divide or multiply to get rid of that number in front of the variable. And then you should be finished at that point, except for you need to check your work. So let's practice this. All right, so what you want to do with a problem like this is you want to look at each side separately. Look at this side of the equal sign and ask yourself, is there anything that I can do to simplify that? And what you can do here is you can use the distributive property to make that a little bit cleaner looking. So it'll be negative 6 times x is negative 6x. Negative 6 times a positive 3 is a minus 18 or negative 18. And there's nothing I can simplify on the right side, so I'm just going to rewrite the number 24. Now this actually looks like something that we dealt with in the last section. So I would move my constant terms to the right side. So I would add 18, and that goes away, and I'm left with negative 6x on the left. 24 plus 18 is 42. And now we're going to divide both sides by negative 6. And I get that x is equal to negative 7. And now, to check my work, I would take that negative 7 and I'm going to put it where I see x. So I've got negative 6 times negative 7 plus 3. Does that equal 24? Okay, so now I'm going to simplify negative 7 plus 3, so I've got negative 6, and inside parentheses I've got negative 4. And negative 6 times negative 4 is positive 24, and that's correct, so I know this is my correct answer here. Okay, so the funny thing about this problem is that people miss this a lot, just because of that silly little minus sign right there. And really what you need to do is you need to think of that as a negative 1, and you're going to distribute a negative 1 to everything inside that set of parentheses. So negative 1 times y is negative y, or you could write negative 1y, there's nothing wrong with that. Negative 1 times a positive 9 is a negative 9 or a minus 9 equals 8. So now what you want to do, again, collect your constants on one side. So I'm going to add 9 to both sides. That creates 0. Don't forget that you have the negative sign in front of the y, so you're left with negative y is equal to 17. And now we want to divide both sides by negative 1 to get rid of that negative sign in front of the variable. So our answer is y equals negative 17. So if I want to check my work, don't forget the negative sign out front. Always go back to your original problem. Negative 17 plus 9. And does that equal positive 8? So you have a negative sign there. Negative 17 plus 9 is negative 8. And then negative times a negative is a positive. So I get 8 equals 8. Yep, that works. This is my solution. All right, so this problem right here, we do have something that we need to distribute to simplify, so we're going to do that. And remember, your closed parenthesis sign is a stop sign. Don't distribute past your stop sign. So I would do 5 times a, which is 5a. 5 times negative 3 is negative 15. I'm going to bring this plus 5 straight down, equals negative 10. Now, check this out. I've got like terms right there, so I can combine those. So I'm going to bring this 5a straight down. Negative 15 plus 5 is negative 10. I would add 10 to both sides. That goes away, so I've got 5a is equal to negative 10 plus 10 is 0. Divide both sides by 5, and I get that A is equal to 0. Almost an offensive answer for all the work that we did, huh? So let's check it and make sure that it's correct, though. So I would put 0 in wherever I see A. 5 times 0 minus 3 plus 5, does that equal negative 10? 0 minus 3 is negative 3, so I get 5 times negative 3 plus 5, does that equal negative 10? 5 times negative 3 is negative 15. And I get negative 10 is equal to negative 10. Yep, that's true, so I know that 0 is my solution. All right, so again, we have a problem that we need to use distribution on. So 2/3 times 6m, I get 4m. If you don't believe me, use your calculator. 2/3 times a minus 3 is a minus 2. And now you have a constant term on the left side and on the right side. You have a variable term on the left side and on the right side. So I'm going to collect my variables on the same side of the equal sign. And I'm going to make that side the left side because m is smaller than 4m. And like I said before, I like to avoid negatives if I can. So I would add m to both sides. And remember, that's a 1m. So that goes away. 4m plus m is 5m. And now I'm going to add 2 to both sides. And now divide both sides by 5. And I get m is equal to 2. And again, check your work. So 2/3 times 6 times 2 minus 3. Does that equal 8 minus 2? So 6 times 2 is 12. 12 minus 3 is 9. 2/3 times 9. Does that equal, I forgot my question mark up there, 8 minus 2 is 6. 3 will go into 3 once. There's 3. 2 times 3 is 6. 6 equals 6 today. That's good. That is my answer. All right, so with this problem, please do not do 8 minus 2 first. That is absolutely not following the order of operations. You have to distribute a negative 2 before you do anything with that 8. So the 8 just gets brought straight down. So I've got negative 2 times 3y is a negative 6y. Negative 2 times a positive 5 is negative 10 equals 0. I have like terms here and here, so I'm going to bring this straight down. 8 minus 10 is negative 2. I would add 2 to both sides to get the constant term on the other side and the variable term on one side. And now I'm going to divide by negative 6 to solve. So I get that y is equal to negative 1/3 whenever I reduce that fraction. So let's check the work. 8 minus 2, 3 times negative 1/3 plus 5. Does that equal 0? So 3 times 1/3, negative 1/3 is negative 1. So I've got 8 minus 2 times negative 1 plus 5 is 4. 8 minus 8, I get 0 equals 0. Yep, that works. Ugh, look at this one. All right, so we need to get rid of some parentheses here. There's nothing inside the parenthesis that we can simplify, so we have to distribute twice. All right, so 4 times x is 4x. 4 times negative 1 is negative 4. 5 times 2x is 10x. 5 times 3 is 15. Bring that 6 straight down. Now let's combine our like terms right here and right here. So I've got 4x minus 6 is equal to 10x plus 21. Okay, so now I want to get my constant terms on one side and I want to get my variable terms on the other. And I compare 4x and 10x. 4x is smaller than 10x. So I'm going to move that one to the right hand side. So I'm going to subtract 4x from both sides. That goes away. I'm left with negative 6 is equal to 10x minus 4x is 6x. I bring my plus 21 straight down. Now I'm going to subtract 21 because I want to put my constant terms on the other side. And so I get negative 27 is equal to 6x. Divide by 6. And I'm going to go up here. X is equal to, let's reduce that, negative 9 halves. All right, so let's check this out and see if it works. Okay, so I'm going to move things around a little bit. Negative 9 halves is our answer. All right, so I had to give myself some more space. All right, so 4 times negative 9 halves minus 1 minus 2. Does that equal 5 times 2 times negative 9 halves plus 3 plus 6? Okay, so let's see here. What do we get here? We get 4 times, that would be negative 11 halves minus 2. Does that equal 5 times, that cancels, so negative 9 plus 3 is negative 6. So let's see here. 4 times negative 11 halves. There's that, there's that. So I get negative 22 minus 2. Does that equal negative 30 plus 6? That's negative 24. Oh, look at that. That's negative 24. So I feel pretty good about this answer. These problems just keep getting longer and longer, don't they? All right, so again, we have brackets this time, and we've got parentheses inside those brackets. Always work from the innermost out. So we're going to distribute this right here first before we do anything else. I'm just rewriting this 10. I'm going to rewrite that bracket. I'm going to rewrite that 3. Now I'm going to write different stuff. So I've got negative 8 times 2s is negative 16s. Be very careful with that s. Don't let your s look like a 5. If you are at risk of your s looking like a 5, make that s an x. I really hate using the variable s anyway. All right, so negative 8 times negative 5 is a positive 40. And I'm going to close the bracket. We got rid of the parentheses by distributing. All right, so now the right-hand side, I'm going to go ahead and distribute here. 15 times 40 is 600. And then 15 times 5s is 75 or minus 75s. Now we need to simplify what's inside the brackets. So 3 plus 40, so I've got 10, and then I've got my bracket. 3 plus 40 is 43. I'm rewriting this minus 16s in here, equals, I can't combine these, they're not like terms, so I'm just rewriting them. All right, so now I want to distribute. Treat your bracket as if it were a parenthesis. It's the same thing. So I'm going to take 10, I'm going to multiply it times both of those. So I get 430 minus 160s. Okay, so now let's decide which side we want to collect our variables on and which side we want to collect our constants on. And out of negative 160s and negative 75s, negative 160 is smaller. Remember, negative numbers, the bigger they get, the smaller they are. So I would add 160s because I'm hoping to get rid of my negative sign. That created 0 right there. I'm left with 430 on the left, 600 right there, negative 75 plus 160 is 85s, and it's a positive. Look at that, we got rid of it. And so now I want to subtract 600. I want to put my constant terms on the same side. So I get negative 170 here. And now I want to divide both sides by 85. So I get that S is equal to negative 2. All that for negative 2. Goodness. Okay, so now here's what we're going to do. We're going to check our work. So we're going to put negative 2 in everywhere we see S. So I've got 10 bracket 3 minus 8 parenthesis 2 times negative 2 minus 5 equals question mark 15 times 40 minus 5 times negative 2. All right, so now let's do some math. So I've got 10, 3 minus 8. I need to multiply these. I get negative 4 minus 5, which is negative 9. Does that equal 15 times negative 5 times negative 2 is positive 10. 40 plus 10 is 50. So now let's do some more math. So we've got 10, and then I've got a 3, and negative 8 times negative 9 is a positive 72. And what's 15 times 50? It is 750. So I've got 10 times 75, which is 750. That works. This is my solution. Woohoo! All right, so here we go again. So let's go ahead and distribute to get rid of all this mess. All right, so 0.36 times 100n is 36n. 0.36 times 5 is 1.8. 0.6 times 30 is 18. Don't forget your n. And 0.6 times 15 is 9. Now, decide which side you want to put your variables on and which side you want to put your constants on. So I'm going to grab that 18 in because it's smaller than 36, and I'm going to subtract it from both sides. That created 0. 36n minus 18n is 18n. And now I'm going to put my constants on the same side. And now I'm going to divide both sides by 18. And I get that n is equal to 0.4. So now, to test this out, I am going to take that 0.4 and I'm going to put it everywhere I see n. So I've got 0.36 times 100 times 0.4 plus 5. Does that equal 0.6 times 30 times 0.4 plus 15? 100 times 0.4 is 40 plus 5. Does that equal 30 times 0.4 is 12? So 36 times 45, sorry, 0.36 times 45, I get 16.2, 0.6 times 27, and I get 16.2. Those two things are equal, so I feel pretty good about that answer right there. Okay, so now that you guys have had a lot of practice with solving equations, I want you to know that sometimes things don't work out as beautifully as we planned. Sometimes you can do wonderful math, do everything perfect, and you don't get an answer. Sometimes there truly is no solution. And that's what a conditional equation is, okay? So, an equation that is true for one or more values of the variable and false for other values of the variable. Okay, so that's a conditional equation is when you have x equals some number. An identity equation is when you have that is true for any value. So x could be 5, x could be 10 in the same equation. No matter what number you put in, it would work. It's crazy, but it does happen sometimes. And then you have something called a contradiction. And that's when it's false for any value you put in. Doesn't matter what value you choose, there's no such thing that would work. And I'm going to show you how you come up with what we've been doing this whole time so far has been this one. We have been doing only conditional equations up to this point. So I'm going to show you guys what happens when you come up with one of these. All right, so this question says classify the equation as a conditional equation, which means you actually get a solution, x equals blah, 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 or in this case. An identity, which means that you have many solutions. There are a whole bunch that would work. All real numbers would work. Or you have a contradiction, which means there are no solutions. And then they want us to state the solution, if there is one. All right, so let's go ahead and distribute twice. Six times -1 is -6. I've got 2n minus 8. Now I'm going to distribute the 5. 10n plus 5. Now I'm going to combine some like terms. On the left side, I've got those are like terms. On the right side, I have this and this are like terms. And I've also got those that are like terms. So 12n I'm going to bring straight down. -6 plus 3 is -3. 2n plus 10n is 12n. And -8 plus 5 is -3. All right, take a look at that. The left side is identical to the right side. So in this case, we have the identity. And what it means when you have the identity is that your solutions are all real numbers. So this is our answer. Now, let me just tell you something. That means that you can pick any number you want and try it out and see if it works. It should work every single time if you do the math right. Okay, so I'm going to pick a number just out of the air. I'm going to pick the number 6. So let's try it here at the bottom. All right, so let's do some math. Let's do this right here. 2 times 6 is 12. 12 minus 1 is 11. So I've got 6 times 11 plus 3 over here. Here I've got 12 minus 8 plus 5 times 2 times 6 is 12. 12 plus 1 is 13. So I'm going to do 6 times 11, which is 66. 12 minus 8 plus 65 is what that is. It's a minus sign, sorry. It kind of looked like a multiplication there. 66 plus 3 is 69. 12 minus 8 is 4. 4 plus 65 is 69. Check that out. So I know that 6 is a solution. Let's pick another number. How about we pick Negative 10. Let's try negative 10 out. And again, just pulled that number out of the air. So I've got 6 times 2 times negative 10 minus 1 plus 3 equals 2 times negative 10 minus 8 plus 5, 2 times negative 10 plus 1. All right, so now let's do math. So 2 times negative 10 is negative 20. Negative 20 minus 1 is negative 21. I'm going to put question marks above those, okay? So I've got negative 20 there minus 8 plus 5 times 2 times negative 10 is negative 20. Negative 20 plus 1 is negative 19. So now I'm going to do 6 times negative 21, and I get negative 126. So I've got negative 20 minus 8 plus, oops, hang on, I'm going to erase that. And I'm going to put whatever 5 times negative 19 is, which is negative 95. So I'm also going to erase that right there. So on the left-hand side, negative 126 plus 3 is negative 123. On the right-hand side, I'm typing into my calculator, negative 20 minus 8 minus 95, and I get negative 123. So that's what I mean. I chose two very different numbers. I chose a positive one, I chose a negative one, and they both worked. So I could do this all day long. If you want to try every single real number, grab yourself a bunch of paper and have at it, but you will find that if you do your math right, no matter what number you pick, every single number works. Every single one. Yeah, it's kind of a pain in the rear, but it works. Okay, so that's why our solution is actually all real numbers. All right, so let's take a look at this one now. So again, classify as a conditional equation, an identity, or a contradiction. Again, conditional means we actually come up with, in this case, P equals some number. An identity means our left side is identical to our right side, and we have P's on both sides, and if we were to subtract one, we'd end up with our P's going away completely, and hopefully our left side is equal to our right side. That is the identity. Identity means it's looking in the mirror. It's looking at its identity. Okay, so that means many solutions. Contradiction means you're going to get something silly and you're going to say it'll end up with your variables go away and you're going to be left with something ridiculous like 5 equals 9, which we know can't be, and that means that there are no solutions at all. All right, so let's take a look at this. So I need to distribute. So I've got 10 plus 4p minus 20 equals 0. I'm going to combine my like terms, so I've got 4p minus 10 equals 0. So I'm going to add 10 to both sides. 4p is equal to 10. Divide by 4. P is equal to 5 halves. Look at that, we came up with an answer. And so now if we try that answer out, it should work. All right, so let's try that out. We only came up with one answer here. So this would be a conditional equation. So it's a conditional, and now we're going to test it to make sure it works. So I've got 10 plus 4 times 5 halves minus 5. Okay, on my calculator, 5 halves minus 5 is 'kay, and now I'm going to do that times 4. Oops, I'm sorry guys, pardon me. I wrote down the wrong number right there. Okay, so that would be, there we go. That's much better. Okay, so now I'm going to do negative 5 halves times 4, and I get negative 10, so I've got 10 minus 10, and there I get 0 equals 0. So that's correct. I know that that's my correct answer. This is a conditional equation because we came up with one solution. All right, so let's take a look at this last one. Again, we're going to classify it as conditional, identity, or contradiction. So we're going to distribute twice, there and there, there and there. So I've got 5m plus 27. 3 times 9 is 27. 3 times 3m is 9m. 2 times 7m is 14m. And then 2 times negative 11 is negative 22. I'm going to combine my like terms on the left-hand side. 5m plus 9m is 14m. Okay, so now I'm going to collect my variables on one side. Look at this. They create 0 on both sides. So look what you're left in. My variables went away on both sides of this equal sign. That means that there is no variable left to solve for. And look what you're left with. Bring this 27 down. Bring this negative 22 down. Is negative 27 ever equal to negative 22? No, not possible. So in this one, we would say this is a contradiction. And there are no solutions to this problem. Doesn't matter what number we try to put in, nothing, no matter what number you pick, nothing will ever work here because 27 never equals negative 22. Now, it doesn't always end up to be 27 and negative 22. It could be 4 equals 3. Something ridiculous is what you'll be left with, that it isn't possible. These two numbers are not the same number. They can't be equal to each other. So anytime you end up with something ridiculous like that, your variables went away, and you end up with something ridiculous, you have a contradiction. All right, guys, that is it for this lesson. If you have any questions, please ask.